Then next topic, resistors combination. Does resistors in series and resistors in parallel. Derivation is there in your textbook, as well as you have to learn the derivation, but guys, it is something which was taught to you guys during your 10th class, I believe. So you guys can get the derivation from either your 10th textbook or the textbook which you are having. It is also there in your NCERT textbook, 12th book, right? So I want you guys to do that as homework. That is how you are deriving resistors in series equation and resistors in parallel equation, right? I'm not going to take it again, right? So I will give you the basic equation, resistors in series and resistors in parallel equation. What happens when two resistors, or let's take three resistors, are in series, R1, R2, R3. The equivalent resistance is, R equivalent is R1 plus R2 plus R3. What happens when three capacitors are in series? You add them in a reciprocal way, that is 1 by C1 plus 1 by C2 plus 1 by C3. What is resistors in parallel equivalent resistance? There are, suppose, similar three resistances and they are connected in parallel, R1, R2, R3. The equivalent resistance is 1 by R1 plus 1 by R2 plus 1 by R3. This much you guys know. You have been taught in your what? 10th, right? So then another equation we would have learned that if the three resistors are common, that is R, three resistors are in series with this having common values, and R equivalent will be R plus R plus R, or I can say 3R. So n resistors of common value when they are connected in series, the equivalent resistance will be n into R. Similarly, if n resistors are connected in parallel, the equivalent resistance will be R by n. This is very easy, guys. Now we'll do some circuit problems with the same topic. Now we'll do the first circuit analysis after learning the series and parallel resistance values. Okay, suppose I'm going to draw a circuit. We'll start with simpler circuit, guys. This is R. Let all of them be R. 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 This is also R. Okay, this is your circuit, and you're asked what is equivalent resistance between A and B. How would you find it? It's very simple, right? This R, and this R, three of them are in series. In series means you add them. So when I draw the equivalent resistance circuit again, it will be R here, then this R is remaining. These three are, when added, they become 3R, right? So that means in place of these three guys, I am writing just a single resistance which is having 3R value, right? Now from the figure itself, R and 3 are in parallel. So in parallel, two resistors, equivalent resistances R1, R2 divided by R1 plus R2. So it is replacing the values here, R into 3R divided by R plus 3R is 4R. Cut off R, you will get 3R by 4. So in place of these two guys, I am going to replace with a single resistance. So the equivalent circuit becomes like this, R, then here 3R by 4, and this is R. And what happens? These three resistors are in series. So R plus 3R by 4 plus R plus R is 2R plus 3R by 4. So it will be 8R plus 3R, that is 11R by 4. That is the equivalent resistance of this circuit. See, this is very easy to solve. When you do a lot of equation or a lot of circuits like this, it will come, or you can solve the circuit within 1 minute. Not 1 time, 30 seconds it is enough. Okay? This much written part I have writing so that you guys can understand. But while doing a NEET examination point of view, need not write. See, I will go on. Let's see the calculation when I am doing. R becomes 3R, 3R and R parallel, so R into 3R by 4R, RR cuts off, it becomes 3R by 4, 3R by 4 is in series with R and R, 2R plus 3R by 4, you can do it, the calculation in your mind itself. So you can solve the circuit within 30 seconds. Clear? Now let's move on to another circuit. Second one. Now let's move on. Suppose the figure is a little bit complicated, but the circuit analysis is very easy. Different circle, okay? First draw a circle like this. This end I am going to keep it free. This is B, this is A. Let's this be 6 ohm. This is 6 ohm. This is 6 ohm, and let this be 1 ohm. Okay. This is a circuit, and you are asked what is the equivalent resistance of between A and B. How would you solve it? See, in this condition, circle, right? So if this point is A, then this point is also A, because they are having same potential. Nothing is in there between, right? So this point A means this point is also A. Then this point is also A, right? Now, this point is different. I'm going to name it as O. Now you're having 3 points, so make it as A, O and B. Now between A and O, between A and O, A and O, A and O, you are having 3 resistances of 6 ohms. So how would you draw it? Between A and O, you have 3 resistance of 6 ohms, 6, 6, 6. Right? Between O and B, I have a single resistance which is of 1 ohm. Completely finished. The circuit is now completed. 3 6 ohm resistances in parallel, that is 6 divided by 3, right? R by N. So 6 divided by 3 is what? 2 ohm, right? So 2 ohm resistance. So the equivalent resistance circuit will be, this is 2 ohm in parallel with 1 ohm, right? So the total resistance or equivalent resistance will be 3 ohm. That's your answer. See, we solved it within few minutes. Right, let's move on to the next circuit. Another one which is much more simpler, guys. When you did the capacitance circuit, you would have been you would have understood how to do this type of circuits, right? Suppose this, I'm going to draw 4 resistances, right? Let's join these 2 guys and these 2 guys, so that this is B, this is A, and this is 4 ohm, this is 6 ohm, this is 3 ohm and 2 ohm. This is your question. I hope you remember this type of question we did in capacitor also. If this point is B, then obviously this point is also B, right? Now I'm going to name this point as C, means this point is also C, right? How would you draw? You will make 3 points for the equivalent, or making the circuit simpler. I'm going to redraw the circuit a little bit different. A, and there is C, and there is B. Between A and C you are having 4 ohm, right, from the figure. Now between C and B there is a 6 ohm, right? Between B and C there is 3 ohm, so that means this is 3. Similarly between C and B you are having 2 ohm. Right, so you have completed the circuit. Now it is easy, right? 3, 6 and 2 are in what? Parallel. So I'm in parallel, right? So I can consider, suppose 6 and 2 in parallel. If you are considering 6 into 2 divided by 8, that is 4, that is 3 by 2, right? Now 3 by 2 and 3 are in parallel, so 3 divided by, okay, I think you are understanding how I am doing, right? Let's make it simplify. Okay, see, these 3 resistors are in parallel. So in actual way, as per the textbook, what would you do? 1 by R equivalent is equal to 1 by 3 plus 1 by 6 plus 1 by 2. You make the LCM 6. So this becomes 2 by 6 plus 1 by 6 plus 3 by 6. So it becomes what? 5 plus 6 by 6. Right. So it will be 1 ohm. Right. So I hope you understood. The other way is I took only 2 resistances, I considered them parallel, then that equivalent resistance I consider with the parallel condition. Both way is easy. You might not do a calculation, you can do it in mind itself. This much clear, right? Right. So you got an equivalent resistance here, that means 1 ohm. 1 by R equivalent is 1 ohm, means R equivalent is also 1 ohm. So here in place of these 3 guys I will write 1 ohm. So the equivalent resistance circuit will be 4 parallel 1 ohm. right? This is A and B. What is the equivalent value now? 4 plus 1, that is 5 ohm. That is the resistance between A and B. Yeah, even if the circuit looks complicated, the solution is very easy, or solving it is very easy. Now we'll go for the last circuit, guys, of the simpler version. After this, we will do a little bit complicated circuits and different methods of solving. Right, 20. In CBSE point of view, they don't, last year they asked, but normally they don't ask this much complicated, not this much. Questions which I have planned for you guys, they don't ask that much of tough questions, but for NEET as well as JEE point or KEEM, they do ask. So we have to be fully prepared. So I'll make sure that you are doing almost all the complicated circuits. Right, okay, I wrote 20. This is your circuit, and you are asked what is the equivalent or resistance. How would you solve it? It's very easy. If you look into the figure, this 20 ohm and this 20 ohm both are in parallel. So what is the equivalent resistance? R divided by 2. So 20 divided by 2 is 10 ohm. So this is 10. This also becomes 10. Right, replacing these two guys. Then there is a 10 ohm here, and there is a 20 ohm here. There is a 20, then 10, and there is a 10. I'm not going to write the values now, later on. Now this 10 and this 10 are in what? They're in series. So if they are in series, what would I do? I add them. So the equivalent of this 10 ohm resistance will be 20 ohm. I'm going to write here 20. Yeah, so now I'm not going to consider these two guys. I'm going to consider this 20 ohm only. And what is the value of this resistance here? 20, right? Right. So what is 20 and 20 doing now? They are parallel. So two resistance, same value. Parallel means 20 by 2. That means now in place of these two guys, I can replace it with a 10 ohm. Now I'll make a new circuit. So this is 10. Right. This was 10, I think. This was 20. Right. This was 20, right? Now this 20 and this 20 parallel, they became what? 10 ohm, right? So they are 10 ohm. Right. Now we will make it as this. This my circuit is completed. This is 10. Right. Now this 10 ohm and this 10 ohm are in series, because if the current flows here, the same current goes over here, and then there is current is same flowing here. So this 10 ohm and this 10 ohm are in series. So what will be the equivalent circuit again? 10, 20, and these two guys are to be replaced by again 20 ohm. Right. Now 20 and 20 are in parallel. What happens when they are parallel? What happens? It becomes R by 2. So 20 by 2 is 10. So 10 ohm, and this is 10 ohm, right? 20 by 2. And they are connected in this way. Now 10 and 10 are in parallel, right? Right. This is B, this is B, this is another point C. Right. So 10 and 10 are in parallel. 10 and 10 in parallel. So it is 10 by 2, that is 5 ohm. So the equivalent resistance circuit becomes like this: 10, and there is 5 ohm. And these two are in series. So the equivalent resistance, R equivalent, or final answer is 15 ohm. Right. Now we will do another circuit also. We have time for it. So this is a circuit which I am going to draw. It looks complicated, but solving is very easy, guys. There is a crossover like this, a jumping. Jumping means this circuit, that is this 12 ohm and this 6 ohm are not connected. This wire has jumped over and connected to this point. Right, I have marked it as ABCD A, and after that 1 ohm means there is another point C, right? So this is point D. Now you can name if this part is wanted or not, but you can look at the circuit and you can understand this 1 ohm and 5 ohm are in series. It is very easy to solve, right? A problem comes, see, this point is B, means this point is also B and this point is also B. This much should be clear. Now we start with solving it. From the first step itself, this 1 ohm resistance and this 5 ohm resistance are in series. So what would you do? You add them. So the equivalent resistance will be what? 6 ohm, right? The equivalent resistance will be 6 ohm. So this much part I can remove. Now this 6 ohm resistance and 4 ohm resistance is in parallel from the naked eye itself. Is there anything else which is parallel? Yes. See, I'm going to mark the points D and B separately. Suppose this is my point D and this is my point B. First, between D and B you can easily say there is a 6 ohm, there is a 4 ohm. Now let's move back to the diagram. D and B, there is another resistance which is 12 ohm. So I have to draw that also. So there is 12 ohm. Right. Now this much part we will solve, then we'll replace the part or the equivalent resistance here. Right. Now 12, 4 and 6 are in parallel. What would you do? You have to find the equivalent resistance. That is, let's see, take 12 and 6 first. R1, R2 divided by R1 plus R2 is 18. So 6, 18, that goes 3 and you will get 4 ohm. Right, so a parallel combination of 12 and 6 gave you 4 ohm. Now this 4 ohm and this 4 ohm are in parallel. So R by 2, that is 4 by 2. So the equivalent resistance of the entire combination is 4 by 2, that is 2 ohm. That is in between so D and B you can replace the entire combination with the resistance of 2 ohm value. Now I am going to redraw the circuit, okay? Listen to it. Now A, there is 1 ohm resistance. Right. Now C, then there is a 1 ohm resistance. Then comes the point D. Now I am going to replace between D and B with the 2 ohm resistance. This becomes B. From C to B there is a resistance of 6 ohm. Right. Now there anything else? Yes. Between 6C and B there is a 3 ohm resistance also. So I am going to write this 3 ohm. Your circuit is completed. Got it? So this is between A and B. Now as you can see, this 1 ohm and this 2 ohm are in series. So I'm going to replace it with another circuit, 1 ohm, and this is C, this is B. So there is 3 ohm, then there is 6 ohm, and there is a 3 ohm like this, 6, 3. Right, now this 3, 6 and 3 ohm are in parallel. So what is 3 and you can take it as 6 and 3 if you are taking, that is R1, R2 divided by what? R1 plus R2, this is 3, that is 2 ohm. Now this 2 ohm is in parallel with 3, that is 2 into 3 divided by 5, that is 6 by 5. Right, now this 6 by 5 and 1 ohm are in series. So it is 1 by 6 by 5, or it is 11 by 5 ohm resistance is the equivalent value of the circuit. Clear? Okay. Now guys, in first look almost all the circuits look very complicated. Lots of resistors in a circuit doesn't mean that that circuit is tough. It just means you will take a slight bit of time more. Right, so whenever you look into the circuit, always find that part of the circuit which can be easily solved. Always find those parts which are series and always find those parts which are parallel. How can I say whether a circuit section is series or not? When the current is flowing through two resistors and they are same current, they are flowing through the same resistor or different resistor, then those resistors are said to be in series. Whereas if the current is splitting, it becomes parallel. It's just a common section, but some of the circuits will be done later on by me, and I will send it to you through the video, where you can never understand whether the resistors are in series and parallel. Those circuits are tough. Okay, this and all, today's work is very easy. Clear?